5 years ago, 1 petaflop of AI compute meant a rack of servers in a cooled data center. NVIDIA just put it on a single chip that fits inside a laptop. It's called the RTX Spark, a Grace Blackwell Superchip, 128 GB of memory, the full CUDA stack, running natively on Windows. The supercomputer didn't shrink. It moved in. The RTX Spark is the consumer face of NVIDIA's GB10 Grace Blackwell Superchip. Superchip means 2 processors fused as one, a 20-core ARM Grace CPU and a Blackwell GPU, sharing a single 128 GB pool of memory. No copying data back and forth, they read the same pool. NVIDIA already sells this as the DGX Spark desktop. RTX Spark brings the exact same silicon to Windows laptops and mini desktops. Here are the numbers that matter. 20 ARM CPU cores. A Blackwell GPU with 6,144 CUDA cores and 5th-generation Tensor cores. 128 GB of unified memory at around 273 GB per second. 1 petaflop of FP4 AI throughput. All etched on TSMC's 3nm process. Each one of those is a data center class figure. Together, in a PC, they're unprecedented. Here's the mechanism. On a normal PC, the CPU and GPU each have their own memory, and large AI models choke moving data between them. RTX Spark gives both a single 128 GB pool, so a model loads once and stays put. On top sits CUDA, NVIDIA's software layer, running natively on Windows for the first time. CPU, GPU, one memory, one software stack, that's what turns a PC into an agentic AI machine. Picture the difference. A normal AI PC splits memory, the CPU has its RAM, the GPU has its own, and every large model has to be sliced and shuttled across a narrow bridge. That copy is where speed dies. RTX Spark erases the bridge. One 128 GB pool, addressed by both. A 70 billion parameter model that won't even fit on a typical gaming GPU loads whole, in one place. That's the unlock. Why should you care? Because 128 GB of unified memory is enough to run, fine-tune, and prototype large AI models on your own desk, privately, offline, with no per-token cloud bill. Work that used to require a rented data center now runs on hardware you own. NVIDIA frames it bluntly, your PC goes from a tool you operate to a teammate that runs tasks alongside you. That's the real product, local, agentic AI. And it's not narrow. The same silicon serves 4 very different users. Developers fine-tune and run big models on device. Creators get FP4 acceleration, RT cores, and color-accurate 4:2:2 encode for real-time timelines. Agents run tasks autonomously, offline. And gamers get ray tracing, the full DLSS suite, and reflex. One superchip, for workflows. That breadth is how it reaches the mainstream PC. To see why this is a leap, put the AI throughput side by side. Apple's M4 Max neural engine lands around 38 trillion operations per second. AMD's Strix Halo, roughly 50. RTX Spark targets about 1,000. These aren't identical formats. Spark's figure is peak FP4 with sparsity, but the order of magnitude is the story. It isn't a faster laptop chip. It's a different category of machine. But raw numbers aren't the whole game. Apple's M4 Max also offers 128 GB and even higher bandwidth, but no FP4 hardware and a much smaller neural engine. AMD's Strix Halo pairs Zen 5 with a big integrated GPU at a lower system price, but again, no FP4, and critically, no CUDA. That last word decides it. RTX Spark wins not on bandwidth, but on FP4 plus the CUDA ecosystem every AI developer already lives in. Follow the money. The DGX Spark desktop sibling launched at $39.99, then NVIDIA raised it to roughly $4,700, blaming memory supply. Consumer RTX Spark laptops are expected to start lower, likely above $1,500, climbing steeply for the full 128 GB models. But notice where the value really sits. NVIDIA designs the chip, TSMC fabs it on 3nm, Windows gains an agentic layer. Whoever buys the laptop, the margin flows to the same two companies. And this is only Generation 1. At Computex 2026, NVIDIA laid out a 3-generation roadmap for the PC. GB10 is the start. Next comes Rubin, moving to faster LPDDR6 memory. After that, the Rosa and Feynman generations. NVIDIA isn't testing the PC market, it's moving in for the decade, the same way it owns the data center. The bottleneck to watch is memory supply, which already pushed prices up once. So what's the durable advantage? Not the teraflops, competitors will match those. It's the choke point underneath. CUDA is the one software stack the world's AI is built on, and RTX Spark brings it to the PC natively. TSMC is the one fab advanced enough to print the chip. Put those together and you get lock-in. Developers build on CUDA, CUDA needs NVIDIA silicon, and the silicon needs TSMC. RTX Spark is how that moat reaches your desk.
Remember one thing about NVIDIA. The chip is the bait. The software is the hook. Every petaflop they put on your desk pulls you deeper into CUDA, and CUDA only runs on their silicon. That's not a product. That's a moat with a power cord.
One chip, one memory pool, the whole CUDA stack, a data center class AI computer, on a PC you own. If this changed how you see what a laptop can be, subscribe to Technologia today, where we break down the tech actually shaping tomorrow. The supercomputer didn't shrink. It moved in.